Good day, everyone. Welcome to BST African Electronic Surgery on a Wednesday. And let's fix something, guys. We do have this power pack which came in from one of our regular customer. And what did he say? The power pack has no output, no power. So, how much you can charge in fixing a power pack? Here, the local market power packs, they are ranging around 15 US dollar to 20 US dollar, depending on the model of the power packs. So we're charging 10 US dollar for a repair, which is fair. It's all about country, because if a new one is going for 20 and I charge you $10 for a repair, to me it's fine. So that's the power pack. Let's plug in the power pack on power. So I've plugged the AC adapter only, just to separate the fault if we have the AC adapter or the power pack itself. So let's check the voltage. You must have 220, 230 AC, 215, which I believe is fine. So plugging in the power pack. This power pack has no light or no anything, but you can switch to DC and check the output voltage, and it is 0. You can see on the screen 0. The outer metal is the ground and the inner one is the plus, and we have 0, no output. So today we'll learn how to fix this quickly. So yeah, the power pack has been tightened with the rubber bands. The customer is trying to protect the power pack. Right, the inside of the power pack. So what is the first step? We are now inside our power pack. What is the first step? The first step is to check if the big capacitor has got voltage. Otherwise, you get electrified. That's the first step. We need to check if our big capacitor is it still charged or not. Like 0. That means we are safe. You can touch, you can do anything. We are safe. Okay. Second step, visual inspection. Looking for like a cracked solder, cracked joints, things like that. I can't see anything. The third step, putting your multimeter on the beeping mode, diode mode. Start checking some fuse, some things. Fuse. The fuse is gone. The next, big capacitor. I can't see any short. Rectifier. The minus pin of the rectifier is shorted to the AC in. What about the switching Mosfet? The switching Mosfet is reading a short. The rectifier is reading a short. So it's possibly we have like 2 faults here. It's very possible. So this should be a quick repair. Let's check out the let's take out that bridge rectifier and check if we still have a short. The rectifier is out. The next step is to check for short again. We don't have short anymore. And the switching Mosfet, we still have a short. No, that wasn't a switching Mosfet. These are the pins of the heatsink. You know I'm crazy. The switching Mosfet is here. You know, I can't believe. Checking on the Mosfet is here. Drain to source is shorted. So even the Mosfet is reading a short there. So let's take down the Mosfet and try. Our Mosfet is out. Very simple. Let's check down. What we can do if the customer doesn't have money to buy a new power pack, we have to fix the old one. Checking again, drain to source. Good. Straight on the Mosfet. You can see the Mosfet is shorted. Okay. So we have like three problems. So the fuse blown up after these two components get shorted. This is a bridge rectifier which is changing from AC to DC. And this is the switching Mosfet, because here we have a ferrite transformer here, the switching transformer. So this Mosfet is switching the transformer. It's communicating with the driver, because here we have the driver here, which is sending signal to the primary stage of the transformer to switch on the secondary using a device called optocoupler and the TL431 shunt regulator. So that's how the things work on a switching power supply. So the first pin is gate, drain and source. So drain to source, we have a short. So let me look for a rectifier and a switching Mosfet and we replace. So what did I found? I found this power pack. We do have the rectifier here. So we'll check out this rectifier. We need a rectifier and a switching. So how are you guys? I hope everyone is fixing things. I hope everyone is fixing. That's the rectifier. We also want a Mosfet. We take down this Mosfet. We check. Hopefully these components they are good. I will take also the fuse. Today I want to do like proper job. No replacing a fuse with a wire. That's our fuse. Well, today I'm not gonna using calibrated fuse anymore because I think that is a bad example. I don't want to be a bad example. So let's check those components quickly. The fuse is good. Our rectifier looks good. The MOSFET itself. So you understand why this board is there. This MOSFET is gone. Let's try to look for a proper MOSFET. We found the rectifier. Now it's now hard to find the MOSFET. Where's my MOSFET? Where's my MOSFET from this thing? Or it's stuck with some kind of glue. I think the MOSFET is stuck with some kind of glue here. It's hidden here. I can break this. That's not a big deal. These are just boards for space. I need something to hold up because we need to take that MOSFET. Hopefully it's good. Hopefully this time we have a good MOSFET. This is a channel N MOSFET which is being used. But before, on old electronics you find NPN transistors like CRT boards for those old TV boards and all other old electronics. They were using transistors. And now everyone is using MOSFETs these days. Every manufacturing company they switch to MOSFETs because of their efficiency and because MOSFETs they are voltage controlled, but transistors before they were current controlled. So that's the difference. But all they are switching devices. All they are switches. Nothing, no big difference. That is small guy, which was struggling to take out. Hopefully our struggle means something here. Let's check this Mosfet. K3669. The Mosfet looks good. Straight away, let's replace the Mosfet first. We want a working power pack here. That's all what I want. Where's my soldering wire? Soldering wire. Soldering back the Mosfet. Good. Now the second step is to put the bridge rectifier or a rectifier bridge. Let's do it. Let's do it. It's not hard, guys. Nothing hard here. Nothing hard, but you need patience. Soldering all the pins of the rectifier. First pin, second, third, fourth. Now we can come with the fuse. What I will do, there's no space here to solder this fuse from inside, so I'll put it here on the back. That's our input fuse. I'll solder this fuse here. And I'm sure everything should be fine. Our fuse is now in place. So do you think it will blow up? Or do you think this MOSFET is going to switch this kind of transformer? All looks fine. All looks fine. So what I'll do, let's put this thing temporarily inside and try. There are two options. Either if you miss something, this is going to blow up again, or we are going to have a working power pack here. Two options. Let's measure the output. Nothing blow up. Let's measure the output voltage. We now have 19. No. No 19. It's not working. It's not working. Big capacitor. The capacitor is too charged. I believe the MOSFET is not switching. Let me look for a different MOSFET. So I suppose we need to check further what's going on here. We need to check further why we don't have output. Any short on the output, plus and minus, not shorted. Okay. The red wire just fall out. Okay. So that's clearly why this power pack has no output after replacing the rectifier bridge and the switching MOSFET. Do you see? Let me check straight on the output here. $19.47. You can see. So we now have out 19.47. You see. So we now have the output on the charger. So that's basically how you fix the power pack. So let me unplug here and put back all together, and then we'll test. I think we need to solder back the plus wire. We just jump out of the socket before closing up. I never trust these small power packs. The chances of being electrified, they are very high. looks better. Now all what we need to do is to put back this power pack. That's all what we need to do here. So instead of using customer's rubber band, we'll stick this power pack with hot glue right round. Hot glue here, and this side, and this side. That's all what you need to do. So we just save $10 of the customer, because instead of buying another power pack at 20, you can still use this old power pack at the cost of $10, which is fair. But I believe to some developed countries that $10 can buy a new power pack. But this is not like developed country. This is still, we are still living in the ages here. So people, they are putting prices they want, they sell the things they want with their own prices, putting abnormal profits. That's what you found, especially in Africa. What you can do, this is Africa. So we found like 3 culprits. This blown up fuse, you see, the blown up fuse, the rectifier, source shorted from the plus to the AC in, shorted. All the pins of the rectifier, we have minus, plus, the live and neutral, should not beep to each other. That is a sign of a shorted bridge rectifier. On the Mosfet, we have gate, drain, and source. This is an N-channel Mosfet. Also, the pins should not interbeep. If we found any pins interbeeping to each other, like here, drain to source 0, that's an indication of a fried Mosfet. So I'm happy, and my customer will be happy also, because we now have a working power pack. Check on the screen, 19.48. Our power pack is working fine. So I'll stop this video now. Like, subscribe, don't forget to turn on the notification bell. Also, like, comment, and share our videos. See you on the next one. Bye.